it doesn't necessarily mean that we will not come back to this topic. After you guys open, we will still have to redo this topic. At least by that time, you will be having a better understanding of what the topic is all about. Even when they do it in class, you will definitely be in a position where you are able to understand better. So now I think my screen is sharing. Let me just quickly check with all of you if you are able to confirm if my screen is sharing. Guys, is my screen sharing? Can you be able to see on my screen?
Yes, sir.
Okay, then it's fine. So I'm just mute. I'll say allow participants to unmute. Okay, I will say yes on that one. Okay, so guys, very quickly, let's have a look at some few examples. So in today's lesson, since we are concluding on this topic, I will need some of you guys to be involved in the calculation parts. And you will be commenting in the comment section as you always do. So remember, guys, we said we do have what we call a cell, but the moment I have more than one cell, then it's called a battery. Then you can have, maybe let's say, an ammeter there, and then you can have another type of a connection there. Let's keep it simple. Then we'll say we have a resistor there. Say that resistor is 2 ohms. We can still have another one there, which is 3 ohms. We can have another one there, which could be 1 ohm. Maybe another one there being 2 ohms. In terms of the V, let's say we have 20 volts. Maybe this one, let me work it out on my own. Then only after this, I will give you guys something to quickly work out. So the questions corresponding to this electric circuit are as follows. Number one, they can request you to calculate R total, being total resistance of the electric circuits. The reason I took a pause is because I wanted to add something there and say, let's refer to that as V1. And then let's refer to that as a V2. Yes, V2. Then I would like for us to refer to that as V3. Yes. Okay, number one are taught. Number two, they can say reading on ammeter. Then number three, they will say reading on V1, V2, and V3. So these are the questions that I'm going to be answering. And then on the next question, I will give you guys something to very quickly work out so that you can check if you'll be able to answer these questions if you are given a drawing and they want you to answer the questions. Before I start answering the questions, let me check if there's any one of you guys who needs clarity on something. Does everything make sense there? Even the questions themselves. Do you understand? Let me ask all of you guys to unmute and let me know as we conclude on this topic. So guys, any questions regarding that drawing in the questions, or is it fine? I can continue to answer the questions. Okay, then it's fine. Remember, soon as I'm done answering the questions, I will give you something to very quickly work out and give the answers. So, I am definitely going to answer these questions as if I'm in an exam room, just so that you've got a sense of at what pace you should be answering these questions, and also what goes into my mind as I interpret the given information and as I interpret the questions. Let me that honorable member. Okay, so guys, this is me in an exam, and I'm on that question. I'm given an electric circuit. I can see there is 20 volts in terms of the V, and I have 2 ohms and 3 ohms connected in series. I have a parallel connection there of 1 and 2 ohms. And I also have V1, V2, and V3. The first question they want me to calculate are taught. Guys, with regards to question number 1, there is only one formula to calculate R taught, and the formula says R taught is equals to R1 that you plus it with R2 that you plus it with R3 and other resistors which may be connected in series or in that electric circuit. I can start from the left and say R1 is 2 ohms. But when it comes to the other part, those resistors are connected. So that's why for now, I'll just substitute R parallel there. And then there is that one which is 3 ohms. It's unfortunate I cannot conclude on R total because I do not know what R parallel value is. So that means I need to now work out the R parallel. How do you work out the R parallel? On that same calculation, as you continue, say 1 over R parallel is equals to, you firstly start with the formula. R1 plus 1 over R2. And then what you do, you substitute 1 over R parallel is equals to 1 over, I can start with the one at the top being 1, you say plus 1 over, the one at the bottom is 2. Then the third step, you just say R parallel, no longer 1 over R parallel, but you just say R parallel, it's equals to, you say 1 over 1, that you plus it with 1 over 2, you close, you say to the exponent -1. You will always do it like this. And then what you do, it is to punch that on your calculator. So you have 1 over 1 that you plus it with 1 over 2, you close, you say to the exponent of -1, it gives you 2 over 3, but you must write it as a decimal, which is 0.67 ohms. So that means that connection of parallel, when it is combined, when we say when it is combined, it's like you converted it into a single resistor. If it is a single resistor, it has a resistance of that 0.7 ohms. I'm just explaining to you what that formula does. So that you don't need to show in your calculation. It was me just trying to explain. So now you can finalize your answer and say, okay, I had my 2 ohms there that I need to plus it with 0.67 that I need to plus it with 3. So finally, it looks like you have 5.67 ohms as your total resistance. So that's how you answer that first question, honorable members or members who are honorable. So now, when coming to the second question which says the reading on the ammeter. So every time when it comes to the reading on the ammeter or the reading on the voltmeter, always remember this formula which says V is equals to IR. When it comes to R total, it is this formula that you need to remember. Also remembering that in case if there is a parallel connection, this formula you will need to use. So now that they want me to calculate the reading on the ammeter, so always when they say reading on the ammeter, they want you to calculate that I on that formula. So now let's see. Okay, in physical sciences, you always start by writing the formula. So you will say V is equals to IR. What is V? It is given as 20 volts. I, it's what you are looking for. You did calculate the resistance, the total resistance as 5.67. So because it is the I that you are looking for, why do you not divide both sides by that 5.67? Why do you divide by that? It's so that it cancels. As it cancels, you just remain with I alone, which will be equals to, then you go ahead and say 20 divided by a 5.67, and it gives you 3.53. 3.53. I is measured in amperes. So that is how you would answer that question, honorable members, regarding the reading on the ammeter. So it's like we are saying the electricity that is flowing there, it is flowing at 3.53 amperes. So it is that electricity that is flowing through that circuit. Even though when it gets there, it means that 5.53, it splits. Some of it will go to this side, and then some of it will go to this side. And then when it gets there, it joins again, it moves as 5.53. So that is the difference, or this is what happens when it comes to a series and parallel. So for example, let's say that current, let's say it was 4 amperes as an example. So that means when it gets to parallel, maybe 3 will go through that side. 3 amperes will go through that side. Then automatically 1 amperes will come to this side. And then when it gets to that point, it joins 2 back to 4. That's what we mean when we say parallel connection. So as we go deep in this topic, we will try to find out exactly how much is going through that side and exactly how much is going through that side. That's when we go deeper with this topic. But for now, we'll just leave it at that stage so that you are not being confused before you get used to this topic. Okay, so now I will get to the last question, which says the reading on V1, V2, and V3. So remember, the formula remains V is equals to IR. So in this case, I'll be calculating a V1. So the question now is, what is the current passing through where V1 is connected? What is the current that is passing through there? It is that same current there, honorable members. It is that same current. The only place where it changes, it is at that parallel connection. But anywhere else, it is that 3.53. Remember, V1 is connected across there 2 ohm resistor. That's why on that R, I substitute that 2 there. So now, let us see. That means you're going to go ahead and say It looks like I need to switch on the light so that I see my calculator. But you can punch it on the side just to see for yourself what the answer is supposed to be. Okay, 3.53. 0.53, you double that, it gives you 7.06 volts. So that means V is measured in volts. And then when it comes to V2, so V2 again, you'll say V2 is equals to IR. So that means in every series, it is the same, except when it gets to a parallel. So that means the current again, it is 3.53. The RV2 is connected on the 3 ohm resistor. That's why I substitute 3 there. So that means we'll say 3.53 multiplied by 3, it gives you 10.59. Remember, it is measured in V. So now, when it comes to a V3, still you say V3 is equals to IR. And then what is now the current that is passing through where V3 is connected? So can you guys see? V3 is connected on that parallel connection, where in this parallel connection, trust me, the current that is passing through that side, when you combine it with the current that is passing through this side, it takes you back to that same current there. So that means, honorable members or members who are honorable, the current that is passing through that parallel connection, it is still 3.53. So you need to be careful when you substitute R. The R is not for 2, the R is not for 1. Why? Because the R that we are substituting with, it is the one for the combined. So if you see yourself using the R for 1 or the R for 2, just know that you are wrong already. So that means you must use the R for the combined, which is what? 0.67. Then you'll say 0.67, you multiply that by 3.53, then it gives you 2.37 volts. So that is how you calculate the V1, V2, and V3 readings. Then you are done, honorable members or members who are honorable. Let me then show you something. We just calculated V3, isn't it? We just calculated V3 and we said V3, it is 2.37, not amperes, but volts. I want to show you guys something. So if you now want to know exactly how much of the current is flowing through that side and exactly how much is flowing through that side, you will still use that same formula. You will say V is equals to IR. Then in this case, what is the V? It is that one, which is 2.37. You now want to know the I that is passing through that 1 ohm resistor. So that means here, in terms of the R, that's when you substitute that one. Then you divide both sides by 1. Trust me, current through the 1 ohm resistor, it will therefore be equals to 2.37 amperes. Then, if you want to know the one that is passing through this side, you still use that same formula which says V is equals to IR. Then you still use that same V of 2.37, which is equals to the current on the 2 ohm resistor. So that means here for R you substitute 2. Then what you do, you say I on that 2 ohm resistance equals to that 2.7 you divide by 2. 2.37, I meant to say, divided by 2, then it gives you 1.19 amperes. So now you know how much of the current goes through that side and how much of the current goes through that side. That's when you go deeper into the parallel connection. So now let me see. Did you guys see what if you've been attending since the beginning? But if you've been skipping the classes, it might be challenging, which is where now I will have to encourage you to catch up on the lessons that you missed. So now let's see, guys, any questions for me before I give you something to quickly work out? Guys, any questions from your side, or are you ready to work out something on your own and see if you can manage? Okay, no questions, then it's fine. It's fine, it's fine, it's fine. I will then give you guys something to work out very quickly. You will comment in the comment section and I will quickly take you through corrections. So now let's see. This is a cell. The moment you put 2 or more, we call it a battery. And then this is a conducting wire. The moment you do that, it means now you are introducing a parallel connection. And then we can still do that. Maybe here we can connect a device there called ammeter. And then we can have that, maybe let's say 3 ohms there, and then let's have that. Maybe let's have, again 3 ohms. And then there, let us have 2 ohms. Let us have 2 ohms. In addition to that, let's have V1. So the questions will also be the same. Here, let's have our V2. Then there, let's connect our V3. And also here, let's say we have 20 volts. That is the power of that battery. And then now comes the questions. Question number 1. Obviously, you calculate R total. Number 2, a reading on ammeter. Reading on A. Number 3, reading on a V1, V2, and V3. Almost exactly what I did. It's what is expected of you to do. Maybe let me zoom in a bit so that it's clear. Okay, then it's fine. Very quickly, let me check. Guys, is it clear in terms of what you need to do? You can unmute and let me know or comment in the comment section. Guys, is it clear regarding what is expected of you there? So that means when you answer those questions, you will say, number 1, this is the answer. Number 2, this is the answer. Number 3, and so forth and so on, and stuff like that. Okay, let me do this. So something that you need to remember, guys, since it's not maybe let me say it's going to be difficult to find the sign for the ohm. For question number 1, you can just say OHM. That's how you write ohm, the unit. OHM. So that means for number 1, if you get 90, you will just say 90 ohm HM. Then you move on to the next question. The next question is just A. And then that other question, you will just comment and say V1 is equals to that, V2 is equals to that, V3 is equals to that. So I will give you, okay. Yeah, I'll give you 10 minutes, but the first 3 honorable members to finish this question, we will then continue. So an assumption is that if 3 can finish in less than that 10 minutes, it means averagely, most of you guys should finish within that time. So this is, for example, to avoid a situation where I say, I'm giving you 30 minutes on this question, only to find out that it can be done in 5 minutes. So based on how long it takes 3 of you to finish it up, then we will continue from there. But I will give you a full 10 minutes to work it out. Okay, that means on my side, I'll just be waiting as you work it out. Maybe let me allow those who get stuck as you work it out. In case if you get stuck as you work it out and you want to clarify or get clarity on something, it's fine. You can ask, and then I will guide you accordingly, even though might not be direct in my response, but I will just guide you in the right direction. Okay, so guys, are you all on it? Are you all working it out? The same feeling that you are having now, not it won't be exactly the same, but let me say the process that you are expected to go through in an exam room. It's similar to what you are going through now. You need to be able to interpret that given diagram and still be able to answer the questions. Physical sciences is one of the easiest subjects, honorable members. You just need a good teacher for this topic and you will definitely do well in this subject. It involves a simple maths. The maths that you learned in primary, especially grade 7 and 8, it's enough for you to be able to work out questions related to physical sciences as far as calculations are concerned. Doesn't matter whether it's calculations for grade 10, 11, and 12. The math is simple. All that you need is an understanding to say, this is how the current flows, knowing that it is the same current throughout a series connection. Only when it gets to parallel, it splits. Maybe more current goes through the other side and then little current through the other side. But if the resistance on parallel connection is the same, then the current will split equally, meaning half that side, half that side. Then on the other side, it joins back to original. Those are the things that you need to understand. In terms of calculations, primary stuff. So let me just check if there are some answers there. Remember, guys, you won't need to answer one by one. Just work it out from the first question until the last. Then when you answer by commenting in the comment section, you just say number 1, R is equals to whatever ohms, and then the reading on A, that is the current, which is I, You just say I, it's equals to wara wara. Maybe let me give you guys the formulas, even though I'm not supposed to do this because you are expected to know these formulas by heart. Is this one which says V is equals to IR, and then there's one which says R taught in the R's. It depends on how many R's you are having. And the last one is this one for the R parallel, which is equals to 1 over R1 that you plus it with 1 over R2. And that is that. Yes. Yes, 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 yes. Remember I gave you 10 minutes maximum. So that means, let's say at 1940. Yeah. At 1940, we should all be done. Okay. Let me also try to work it out on my side, just so that I'll be able to compare your answers. Yeah. Okay, first question is 7 ohms, second question is that amps, and third question V1 is V2 is V3 is that. Okay, okay. We've got the first answer there. And then
He went back and she said he don't see it. So that's when they
the 3 minutes left. Okay, guys, let's see. Let us see what you guys are having. Most of you are getting 7 ohms as the first one, and then 2.86, 2.86, 2.86. Okay. And then for V1, 8.58, 8.58. Okay. V2, 8.58, 8.58. V3, 2.86. Yes, I'm very much impressed that you guys are getting the same answers, which is a good indication that you are fully understanding. Who are we having there? We have Ethan More, Chloe, Katleho Esona, and Tianeho. Okay, well done, honorable members or members who are honorable. Trust me, that's exactly what you need to know with regards to electric circuits. So normally, normally what happens in grade 11 and 12, you'll still be doing these same things, but now the questions are asked differently. It's like they're trying to test your understanding, and these are not the questions that may come in grade 11 and 12. Even in grade 10, I'll give you an example. They can give you an electric circuit. They can give you an electric circuit like this. Maybe let me say that they, and then say A, do that, and then now they say do that. Let's say V1 there. Okay, let's say you have that, let's say you have that. And what else? Let's say 2 ohms, 3 ohms, 1 ohm, 1 ohm. And then they may say the reading there is 2 amperes. Yes. So can you see now a question which may come? They might say, what is the reading on V1? What is the reading on V1? There's been a question. So I'm going to unmute all of you. If you think you know how to work it out, just mention it. Just mention your name. For example, say Manga. The other one will mention their names. Look at this question and mention your name if you think you can be able to try work it out. Don't work it out. Just look at it and see if you think you can solve it if they want you to answer that question. Anyone? Does it look complicated? Hmm? Guys, does it look complicated? I'm not sure if you guys are able to hear me, but guys, are you able to hear me? Chloe, when you say yes, it does, you mean it does look complicated? Okay. Let me guide you in terms of how you work it out so that we maximize on the remaining time. I want to give you guys an idea of how physics works and how you sort of work out the answers. When they say the reading on V, you need to think of the formula that you need to use to calculate V. We know that the formula is this one, which says V is equals to IR. What is it that you can substitute there in order to calculate V1? I think this is what we already know at this point in time. So that means we have our I, which is 2, multiplied by R, we don't know as yet. But we do know the formula to calculate that R, because the R, it is the R taught, which will be R1, that you plus it with R2, that you plus it with R3. So that means you can say you have your 3, that you must plus it with R parallel, that you must plus it with 2. Now you need to work out the R parallel. Trust me, the R parallel, you know the formula. Let me not write the formula. It will be 1 over 1 plus 1 over 1. Trust me, R parallel, if you work it out, it's going to end up being a 1. So that means now you have 1 there. And then 3 plus 1 plus 2 is 6. So that means your R parallel is equals to 6. No, not R parallel, because 1 is actually R taught, that is equals to 6. So that means you have your 2 there, you have your 6 there. What is 2 times that? It gives you 12. So that means your V is equals to 12 volts. So the reading on V1 will be equals to 12 volts. Did you guys see what you need to go through to answer that question? Of course, I was moving a bit faster because I just wanted you guys to have an idea of to work it out. Someone has worked it out and they got 12. Guys, did you see how to work it out? Okay, then it's fine. It is fine. It's fine. It's fine. Maybe let me try to do what happened. Not sure what happened, but it's fine. Let me do this. We'll also check if, remember guys, on our next lesson, we are going to start with a new topic. A new topic, that means in today's lesson, we are going to take a pause on this one. So let us say you are given, why is this not writing? Okay. You are given that that. So now you have A1 and A2. Okay, let's see, here we had A3. And then let's say the reading on A3, they say it is 3 amperes. Yes. Yes. This is what they give you, honorable members. And then the question comes and they say, reading on A1 and A2. And for this question, they give it 2 marks. And the question says, what is the reading on that? They are not saying determine, they're not saying calculate. They are saying, what is the reading on A1 and A2? Anyone who's got an idea of how you will need to figure out the reading on A1 and A2? Anyone who can suggest how we can try to work it out? Guys, remember, in case if it's difficult, please do let me know. Just comment in the comment section, say difficult, or just unmute yourself and do say that it's confusing or it's difficult, so that I do not wait thinking that you are working it out only to find out that you are finding it difficult. What is the reading on A1 and A2? No idea. Guys, anyone?
It's difficult to say, no idea.
No idea. Atayanda. Okay, Atayanda, do not mute yourself. Let us discuss. Are you still there, Atayanda?
Yeah, I'm still there.
Okay, let's look at how the current flows. Obviously, the current flows from there in that direction. Do you agree that when it gets there, it has to split?
Yeah, I'm agreeing.
Some of the current has to pass through that side and then the other, that side, then it joins. Do you agree?
Yes, I'm putting you.
So the current that is flowing through series connection, how much is that current? Anyone can tell.
It's not 3M.
Yes, 3 amps. So that means that 3 amps, it has to split on that parallel connection. So the question now is, how much of current do you think will go through this side and how much will go through that side? Ayataka, are you still there?
Yes, I'm still there, sir. Yeah. Can you please show me the diagram?
Let me check in the comment section. Anyone who wants to suggest? Guys?
Sir?
Yes.
So I think,
Let's go for it.
I think for A1, I think the answer is, I think it's 2 ohm. I mean, it's 2 amperes, and then for A2, it's also 2 amperes.
2.
Amperes.
Okay, 2 amperes. And then what about A2?
A2, it's also 2 amperes.
Remember, if the total is 3, then when you add the current flowing through that side and that side, they must take you back to 3.
Oh, okay.
1.5 M.
Yeah, you get it now.
Yeah. Makes sense.
I think someone said something there. What were you saying, honorable member?
It's not 1.5 amps, sir.
Why 1.5?
Now add 1.5 to 1.5, we get 3.5 amps.
Okay, let me quickly answer and I will give a reason. So in this case, it's because the soldiers on this side and the soldiers on this side are equal. So that means it is going to split equally. So that means here it is going to be 1.5 amperes. Also, this side is going to be 1.5 amperes. The reason is because resistance on this side of A1 is the same as the resistance on this side of A2. If the resistance was not the same, let's say here, maybe this side it was 6. Nay. In this case, you will need to do the calculation to determine the exact value. But all that we know is that more current will flow through this side. Why this side? Because there is no that much of resistance, or we have very little soldiers on this side. We just have 2 soldiers. So that means more current will run through this side. But this side, because we have too many soldiers, very little current will pass through that side. But only if the resistors are different, you will need to perform a calculation. But if they are the same, you just take the total and you divide it by 2. It will give you 1.5. That's how it splits. Guys, I'm about to end and move on with the grade 12s. Any questions from your side, or are we all okay based on what I've explained?
Okay, so how to calculate these two resistance if they are different? The one is bigger than the other one.
Guys, I'm not sure what happened there, but I was with the grade 12s. Okay, I see what happened. Ma'am, did you join? I was kicked out. I'm trying to figure out. Okay, it's fine. So, guys, before I continue with the grade 12s, all those who were in grade 10 who were attending the lesson, did you understand that last part that I explained? Okay, there was a response saying yes. Then it's fine. So, guys, we are now continuing with the grade. To do, maybe let me mute all and then I'll say no, just so that I'm not being disturbed by the background noise. So the